This is 26. Y equals 2 sine pi x over 2. As the particle passes through the point 1/3, 1, its x coordinate increases at a rate of the square root of 10 centimeters per second. I'll stop and you tell me what this means. One more time. A particle moves along the curve, blah, blah, blah. As the particle passes through, blah, 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 its x coordinate increases at a rate of the square root of 10 centimeters per second.
Distance and time.
Good. How do I write it? Excellent.
dr over dt.
Excellent. But because it's the x coordinate, I'm going to use x. Perfect. Great job. Okay, how fast is the distance from the particle to the origin changing at that instant? Good. So this is a sine function. When x is 0, sine is 0. So something like this. Okay, so I don't care where this point is. Okay, so this is at the end. This is not something fixed. So this does not come into play at this point. So I know a particle moves along this curve, and at any point in time, let's say here, the distance between the particle and the origin, I don't want to denote it by d. I'm going to denote it by anything else but d. Why? Because d is this, the derivative. So I'm going to denote it by w. So this is the particle. The particle moves along this curve with x at any point in time. If it's here, this is x. If it's here, this will be x. If it's here, this will be x. At any point in time, this is its x coordinate of the position. And I have that dx over dt is given to us as the square root of 10 centimeters per second. I'm asked again, let's read it one more time, just to make sure we understand every step. I'm trying to breaking down into little pieces. How fast is the distance from the particle to the origin changing at this instant? So now I'm asking you, what is this? What am I asked to find?
Velocity.
So let's look at the graph. It says, how fast is the distance between the particle and the origin changing at such instant, such and such? So what am I asked to find?
Tangent line.
So that's why we had to have a picture before we had, yes?
dw over dt.
dw over dt. How fast? Thank you so much, Katie. So how fast is the distance between the particle and the origin changing at a particular instant? What is the instant?
So is WR 1/3 and 1?
That's what I said. Don't even look at that. This does not exist. Why does not exist? Because I don't have the function and I don't have its derivative yet. So this piece, so in all these problems, when you see the word when or at the instant or when whatever else, when such and such happens, cross it out from your mind. It does not exist. Till you find an equation for W and then determine dW over dt, anything that follows after when or at the instant does not exist. Okay, let's go back. How fast is the distance from the particle to the origin changing at this instant? Which means this point does not exist till I determine W and find its derivative. Let's go back here. How fast is the length of the pile increasing when? What follows after when, you can forget about it. Anything that follows after the word when has to be plugged in a second before you finish the problem, or less. Okay? So here it says, from the particle to changing at this instant, which means this instant, it does not exist till a second before we present the final answer. I'm going to write it here because that's what it means, but it has to be forgotten. The moment I write it, it has to be forgotten, and I'm going to cover it. See, I have two props. Good. So, one more time, the particle moves along this curve, and any instant is this if you want, or this if you want. I chose this point. This point has nothing to do with anything because I can choose it here. I can choose this. But then it's kind of difficult to show the distance. So I chose a point, a generic point anywhere on the curve. And this is 2 sine pi x over 2. Okay. So we form a right triangle here in which x is the x coordinate. The function is given to us. Can anyone give us the y coordinate? How much is the y coordinate if the point is here and x is this? What will the y coordinate be? What if
Would
this
it also be x?
So what if this is 5? Let's say this is 5. How do I find the height? The y coordinate of this point if this is 5?
Negative.
Plug it in. Exactly. So this height is 2 sine pi x over 2. Okay, excellent. So I have a right triangle where the base is x, the height is 2 sine pi x over 2, and the hypotenuse is w. When the particle moves along the curve, does this change?
Yes.
With respect to?
With respect to the origin.
With respect to time, right?
Well, time.
Good. Does this change?
Also, yes.
With respect to?
X and time.
With respect to time. Does this change?
Yes.
With respect to?
Time.
Excellent. Which means we have 3 functions of time. Function of time, function of time, function of time. X is a function of time, X is a function of time, this is a function of time, this is a function of time, this is a function of time, and this is a right triangle. Is there any relationship between these 3 functions of time that I could write with our eyes closed?
Pythagorean theorem.
Excellent. I'm ready.
X squared plus 2 sine pi x over 2 squared equals W squared.
Brilliant. What do you think I
Why'd
work?
you give it a 4?
I'm sorry?
Why'd you give it a 4 instead of a 2 there?
I have to square.
Oh, because we're...
When we square, we cannot pick and choose. When we have to square, we square everything. Good. What do you think I'm going to do next?
Derivative of both.
Excellent. Can anyone start the first one? Function of time, function of time, function of time.
2x times dx over dt.
Brilliant. Plus
Plus 8 sines
pi x over 2
times pi x squared 2
times the inner function prime times the innermost function prime times
dx
dx over dt. Okay, equals
dw over dt.
2 w dw over dt. Awesome. Awesome. What are we after?
dw.
That's it. All I have to do.
Written on the very far right. I can't really read that.
Say it again.
On the very far right, what is written there?
Dx. Dx over dt. Better? Good. So we're after dw over dt, which means I have to divide both sides by 2w. So I'm going to write it one more time. So 2x dx over dt plus 4 pi sine pi x over 2 cosine pi x over 2 dx over dt equals 2w times dw over dt. Good, so now we know that dw over dt will be 2x dx over dt plus 4 pi sine pi x over 2 cosine pi x over 2 dx over dt. So let's see what we have and let's see what we don't have. Only now I plug in 1/3 for x and 1 for y. And dx, I have that this is the square root of 10. I have that this is the square root of 10. I have that x is 1/3. I have that x is 1/3. And I have that x is 1/3. I'm going to write them one more time, but I just want to explain that this I don't have. But I can take the square root. If I take the square root from both sides, I get what I need. So this piece is the square root of x squared plus 4 sine squared pi x over 2. And I'm going to write it one more time. Any questions so far? Of course, with this being 1/3 squared, and of course in here with 1/3. Okay, one more time. Then dw over dt since y is not there, so I'm just going to write x equals 1/3. So let's see what we have. 2/3 times the square root of 10 plus 4 pi sine pi over 6 cosine pi over 6, because I have pi 1/3 divided by 2, times the square root of 10. Everything divided by 2, the square root of 1/3 squared plus 4 sine squared pi over 6. Okay, now I know that this is 1/2, and I know that this is the square root of 3/2, and I know that this is 1/2 squared, which is 1/4. I need to simplify a little bit before I put all this in the graphing calculator. Okay, any questions so far? Let's take a moment. Let's see if we have any questions here. There is no more calculus here, obviously, it's just algebra. Any questions? So then dw over dt when x is 1/3, let's see. 2/3, the square root of 10 plus 4 pi times 1/2 times the square root of 3/2 times the square root of 10, and these will go away, the 4 with the 4. And this is the square root of 1/9, and 4 times 1/4 is 1. Okay, so this is much better. So what I'm going to put in the graphing calculator, and I see I can take the square root of 10 outside. So I have 2/3 plus pi, the square root of 3, over 2, the square root of 10/9. Okay, this is much better than the mess I had initially. And now we can plug it in the graphing calculator very carefully. So remember, we need parentheses up here. It's a product, maybe, maybe not. Some calculators will work without, but I will put parentheses there, and just to make sure, I will put parentheses in the denominator. It depends on your calculator. The newer ones are much smarter than the older ones.
Why did we drop? Did we drop the 2's that are part of the fractions because of the 4?
Yeah. So, left parenthesis, the square root of 10. Some calculators will pop up with the square with parentheses in there. Parenthesis again, 2 divided by 3, and then plus pi, the square root of 3, close, divide by 2. Let me see, did I close all the parentheses here? No, I did not. Hold on. So, yeah, I need one more. So I have parentheses around the whole numerator. I have the square root of 10. I have 2/3 plus pi, the square root of 3, and this is correct now. Okay, so divided by left parenthesis 2, the square root, and I have 10/9. And another one outside. Okay. 9.16. So approximately 9.16. Measurement unit. So x increased as the square root of 10 centimeters per second. How fast is the distance from the particle to the origin changing at that instant? What is 9.16?
Centimeters per second.
That's it. Centimeters per second. Awesome.
What's with the X?
No, it's not X, it's approximately.
Oh, okay.
Sorry. I wish my X was so nice. My X is like that.